Thank you. Thank you for being here, and very happy to be here. So the idea of this talk is to give an introduction to time series forecasting for data scientists who maybe have done some classical machine learning and have not done much time series forecasting. Hopefully, also those who have done some will find something interesting about this here. Um, The agenda is that I will start to motivate why forecasting, and I will also introduce some motivation on Nixtla, which is an ecosystem of libraries that I will use for the code snippets that I will show during the course. Um, and then there will be a part which will be more slowly paced with a minimal example and showing one of the library of Nixta, which is stats forecast, in which we will take it from the, the basis of time series forecasting, because it's still relevant even though technology changes, algorithm evolves, and everything. And then the third part will be just some bites. I mean, the idea is a crash course, so to just give some highlights of what is possible, give an idea of what the code looks like, and discuss a little bit more about that. And I will then have something that will not go in depth, but just more on the surface. So before that, let me present myself. Hi, I'm Pietro. I come from Italy, from Milan. And I work in a company which is called Agile Lab. We are around 200 people. It's a consulting company. What is interesting, I think, about this company, I joined less than a year ago, so I'm still in the phase in which I can talk about the company without um, well, without being too awkward. So yeah, thank you, thank you. So one thing that is interesting, I think we have a public handbook, and another thing that is interesting, and if you want to talk about it later, we have a self-management system which is called holacracy, in which the idea is you have no boss and the authority is distributed through roles. Before working at Agile Lab, I worked for a number of years as a data scientist in a software vendor, so a product company for the supply chain, and that's where most of my experience from time series forecasting, which is tied then to a specific type of forecasting. It's not particular scientific forecasting. I'm also one of the organizer of the Python Milan and PyData Milan group. So if you want to pass and give a talk there, or you want to pass and see talks, you find us there. You have more links and other stuff on GitHub, and I hope to see some of you in Italy at the end of May. And if you have questions about that, also come talk to me. Okay, so why we are doing forecasting, time series forecasting? So it seems pretty reasonable. I mean, predicting the future should be useful, but I think as data scientists, we always need to reflect on why we are doing something using some complex technology, and we have to kind of provide the business case, the business value. So first of all, there are a number of different domains, and each domains will have different use cases. The domain I know the most in forecasting, the classical domain is say forecasting of sales or in order of demand, like we call it when we talk about supply chain, or for example, forecasting energy consumption. A classical one, although a bit debatable how much you can do with forecasting in these financial assets, but there you have a clear definition of value, making money by changing stuff, and there are a number of other things. I quote weather because it's a completely different set of time series forecasting from what we will see now, because what we will see is based on historical data. And so the idea is that you forecast to be able to take better decisions. So you forecast the demand of your customers, for example, because you want to be able to buy or manufacture the stuff that you need in the product that you are selling, and you need to distribute them through the network and so on and so forth. So reasoning about why we're doing this is important to set to frame the problem. And let's say with respect to the classical machine learning task of regression to classification, time series forecasting is the one that takes times very seriously. It's the most important dimension of your data set. And you'll have to define some things. So for example, you'll have to understand what is the frequency at which you want to do your forecasting. It could be months, weeks, days, hours, minutes, seconds, depending on the use case. You have to think about the time horizon. So how long you need your forecast. So for example, in supply chain, if it takes 2 months to manufacture and then distribute, you need 3 months of horizon. If instead you have just 1 week because you buy and you ship, you have a smaller horizon. So that's another important thing. And the other time-related quantity is the lag, which basically tells you in respect to the time bucket you are forecasting, I don't know, weekly forecast, and you're forecasting the first leg, the second leg, and the third leg. You might have other dimensions which are important to your problem. For example, you can forecast multiple products on different markets, and this leads to forecasting multiple time series. Which is one of the interesting aspects, especially when we will see machine learning coming into place. Okay. So a few words about Nixtla. Nixtla is a startup, a Mexican startup, very interesting, that started in, I think, 2021. I started following them from the beginning. And basically, if we have to summarize what they did, is they made the Python ecosystem strong for time series forecasting. I mean, that's my claim, in the sense that time series forecasting, for example, has been very strong in R, in the R ecosystem, and a lot of things were missing from the Python ecosystem, and Nixtla started doing a lot of libraries which are performant, which have a nice API, and they also picked, I think they had a very good taste in deciding what to implement. So they were not just people who had good taste for code and for algorithms, but also for, I would say, the specific domain. And there are a number of libraries that we'll see. Also notable is that they were kind of the first to launch in 2023 one of the first foundational models for time series. So let's say a ChatGPT inspired model for time series forecasting. Okay. So the methodology that we will take in our first kind of slow-paced example is the classical one, I think, in data science, but I think it's important to go through a little bit. So you have to think about your problem, why you are modeling something in a different way, where you are getting the business value out of this. Because if you have a very nice daily forecast, but you need a forecast over 3 months, you don't really care how to use it. So you really need to understand what you want to do. Then you, as usual, gather your data, you process it, you explore it. Then for me, one of the basic rule or zeroth rule of machine learning is to set a baseline which should not contain machine learning, because that introduces, or advanced algorithms, because those introduce complexity. So you need to be able to justify that, and so you measure and you start improving by testing different algorithms that you pick with certain methods, and you iterate on that. Okay. In terms of data, the hello world, the iris or penguins of time series forecasting datasets is called the air passengers datasets. One thing that I show here that I kind of like also as a very simple choice that Nixla made is a specific choice of the data structure and the name of the columns. These are the default name of the columns. I think that good defaults are very important in libraries. So the defaults in Nixla is to have a unique ID, which will be the ID of the time series. It will not be an ID of the row. A data stamp, a date stamp, and y, the target variable that we want to forecast for a univariate time series. And the first thing that you need to do when you get the data is also to plot the data. So this is just to think about why this is a time series on passengers for a specific airplane company. It comes from a very old textbooks, Box and Jenkins, so it's really the OG of time series forecasting datasets. And what you see here, it's interesting. It's used in many ways because it exhibits a trend and a seasonality that also varies in time. So this is why it's particularly nice. So let's say that we want to start to put in place a mechanism to forecast this. So the first thing that we need to do, as usual, is to split the train and test. And since we are doing time series forecasting and time is the most important thing, we do not do a random split. So this is very important. You do not want to have leakage from the future into the past. And so the split that you always do in time series forecasting is something where you take a timestamp, a date stamp, and you split the train before and the test later. And then you can establish a baseline. In time series, I plotted some of the most common baselines that are used. So the naive baseline is the one in which you take the last value and you just continue giving that last value. The last thing I hear is very good. And in some cases, it can be pretty good. In weather forecasting, the so-called persistent forecast, so the weather of today is the weather of yesterday, is actually not so easy to beat because weather is kind of stable. Then a classical one is the historical average. You just take the historical average, which is good for stationary time series, but we have a trend, so unless we transform the time series in some way, this will not work for us. Another classical one is to have a window average. Instead, if you have a noisy time series in which you want to average the time, but you have something that slowly evolves. So while in our case, I would say the best naive forecast is a seasonal naive because we have something which has seasonality. In principle, we would want something with a trend if you want to have something that is really naive. But baseline can be of this kind of algorithms when you are in a project. Sometimes the baseline is the existing forecasting, which maybe is done through Excel files or something at an aggregated level, and you want to beat it from a disaggregated level. So here is our first forecast with the stats forecast library. And here you see the classical fit and predict API that is now something that we are not confident doing anything else than fit and predict. We are too much used to scikit-learn. But the other thing that you see here is that the stats forecast has a number of available models. The classical ones, statistical ones, are ARIMA and ETS, exponential time smoothing, which is kind of lesser known, but it's a very interesting one. And these are model families that have a number of parameters. So the ETS can have a trend, seasonality, additive, or multiplicative. And so you have also auto modeling in which through information criteria, they will test the relevant parameters and it will select the best one. The other thing that you might want to notice here that is also something that is rather consistent over all Nixtla libraries is that they always provide you with a probabilistic forecast, which is something that in a number of use cases is very important. Maybe you are not really interested in a point forecast. We are interested in making sure that the forecast is in a specific region. In the domain of supply chain where I come from, there is one thing which is called safety stock, which is directly related to the variability of the forecast. So really, the amount of stock that part of the stock that you put in the network is tied to variability. And this is something that for statistical models, you have already probabilistic interpretation, so you can assign confidence levels. But Nixtla has implemented conformal prediction, which is instead a model agnostic technique to do probabilistic forecasting. And from the coder point of view, is just a levels keyword that you add when you predict and when you plot it to show it. Okay. When you have to measure it, as I recall, there is a train and test, but usually when you want to optimize, you want to cross-validate, and the cross-validation in time series is something in which you have to be careful. You usually take different steps in times, and you have also a function to do that in which you define the horizon, so the H stands for horizon there, the step size, so how long you take the steps and the number of windows, how many steps you will take, and it will split automatically a data frame. And this SF object is a stats forecast mod object that we had defined here with the models. That are a list of models, and very easily I can cross-validate and compute a loss with the metric that I prefer. Okay, so this was the first slowly paced part, and now I will talk about some other bigger topics in which I will just touch the surface. So in time series forecasting, I think something that was has been a bit of a milestone has been the M5 forecasting competition. So this has been a competition that has run on Kaggle. I don't remember, it was before 2020 for sure, I don't remember exactly when. And the M5 stands for Makridakis, a Cyprus professor that did this through time. But this one is particularly important because it was not with mixed time series, but all the time series was about a specific domain. It was about Walmart sales daily data with exogenous variable and with a hierarchy of product and markets. So it was really particularly well done. And you see some of the time series here, and in terms of Nixtla, you will see that you have a very nice way to explore some random time series. So when you call plot on a stats forecast object, it will plot randomly some of the unique IDs of the time series. And also Nixtla has this datasets forecast that has a lot of way to has nice utilities to load the data. And indeed, this has been a reference competition in which basically I would say it's the more public benchmark in which we have seen that machine learning models started being the state of the art in a public domain competition in a specific domain. They haven't been used by the leader of the industry before, but in a very public competition with all the explanation, there are a lot of the code of the top performer is published, and so it's been very interesting and something that if you're interested into that there is a lot of material to study there. So since this is the competition that kind of sanctioned the fact, okay, now machine learning models are the state of the art in a very public way, I'll talk a little bit also about ML Forecast, which is the Nixla library for doing forecasting with machine learning models. So when you do machine learning models forecasting instead of statistical, you pass from something which is called local forecasting to global forecasting, which is a big step because before you were using the data of a single time series to forecast that time series, while when you do machine learning, you usually use data from multiple time series. And so it has a big impact because basically if you add one time series to the training set, it can change the forecast of a previous time series just because of that. And so you need to build systems which are reliable if you want to be to work with that. In the case of the M5 competition and in the case of competition with a lot of time series, performance in terms of times is important. And so one of the ML algorithms that has been recognized was the top contender in most of the submissions is the LightGBM, usually with autoregressive models to forecast multiple lags. And here in this API, what you see is a sort of a declarative feature engineering pipeline. So one of the other things that Nixla provides is routines and functions to compute some of the features that you use in machine learning forecasting. So one of the reasons to go with machine learning forecasting is if you want to take advantage of exogenous factor, external variables. But then you need also to be able to use the historical data. In order to do that, you usually create features with lags from the past. And or features from dates, and then if you have other dimensions like the product and market dimension, you can build features, categorical features on that. Another thing that we see here is the target transform. So it's often the case when you do machine learning is that you need to do some transformation on the targets, maybe because there is a trend, maybe because the time series have all different means, and you want to forecast the residues with respect to the mean of the time series. So in one way, one of the things that you sometimes do is basically have a naive forecast with a mean or something like that to do that. Another interesting library is related to hierarchical forecast, and this can be used with both machine learning and statistical forecasts in the sense that many interesting time series problems are hierarchical. If you have products, if you forecast multiple products, products usually have belong to a category and then a brand and then a division. So you have a hierarchy of features, and maybe you forecast across markets, and markets you forecast in a specific store, in a specific country, in a specific region. And so usually at higher aggregation level, there is less noise, so it's easier to forecast, but maybe you need the forecast at a lower aggregation. And so there are techniques to forecast both at the low, high level, and maybe at some of the mid level, and reconciliate the forecast. Because in general, if you use a specific algorithm to forecast at one level below and then one level above, you have different, the sum of the lower level is not usually the higher level. And so there are a number of algorithms that are able to do that. And there are a number of functions to also create the training set with the hierarchy. So to already start from the lower level of the data to generate the time series at all levels that you need to. Neural networks in time series forecasting is something that I would still say is something that is still more of a promise than something that is recognized as the best practice in the industry. There are a lot of different architectures and models. Nixla also contributed one which is called HITS. What they provide here is a library with a lot of the other algorithms implemented, basically all of them, and and a way to experiment with a very similar API that you have in other Nix libraries, so that you can check if for your use case this is useful. There are some neural models which are specific for some use cases. And then finally, you have foundational models. And this, I think, is a bit interesting because, well, they are based on neural networks. So if you want, is an evolution of that. So, and it's the idea of using ChatGPT-like models for time series. And I think one of the interesting part for foundational models is that basically you don't need to train. So you really have, you will depend on an API, you will have costs. But if you need something lightweight that needs to produce a forecast for a small number of time series, which is good enough, it could be, I think, an interesting option. And Nixla is not only one of the providers, there are other by Google, Amazon, Salesforce, and others. Okay, thank you for listening. So there will be not time for questions, I guess.
Thank you for that amazing presentation about forecasting.